And we are back. Woo-wee! Thanks, we got this. I've got a cold, but I'm still doing high energy. Whoa. Take lots of vitamin C. Okay, so next we are on problem number 11. So number 11 is the square root, like a rocket up and to the right. But that 4 is going to make it launch higher. It's going to stretch it up higher. And so what we're going to do is let's see. So we got our parent function here. So here's 0, 0. Wow. Can be like that, huh? Can be like that, smartboard? Okay, so we're at 0, 0. Remember, we usually go over 1, up 1. Good. And over 4, up 2. So that's the parent function. But we're going to go ahead and go, is it left 5 or right 5? Say it out loud. Go ahead. I'm waiting. Good. Opposite what you think. So it actually is going to be left 5. It's going to be left 5. So we go here, left 5. And then instead of over 1, up 1, guess what it's going to do? Well, let's plug a -4 and see. Let's plug a -4 and see. So if we plug a -4 in here, let's see what happens. So XY table. We're going to plug a -4 in. It could be over 1, up 1, which is just equals 1, but I don't think so. I think that 4 is going to be crazy. So we get 4 times the square root of, and then we plug this guy in. Let's do it in red. So we're going to plug a -4 in for x. Plug a -4 in there for x. And then we also have the +5 still under the radical. Okay, so 5 with positive 5 with a -4 is 1. So we get 4 times 1, which is just 4 times square root of 1 is 1. So we get 4. Whoa, that's crazy. So we're going to go right 1, and then we're going to go up 1, 2, 3, 4. So that thing is going to launch straight up. Whoa, nearly straight up. Whoa. It's going to launch. We need one more coordinate, one more point. Now, how do we choose that one? You could put 0 in, but the problem is that you have to choose a number, right? That would give you the square root of 5, blah. So we need a perfect square chosen. So how can we make sure there's a perfect square in there, right? So maybe if we put in, I don't know, maybe x equals a -1, that'd be a good one. Because 5 minus 1 is 4, and we can do the square root of 4. So we'll try -1 for our x value. So 4 times the -1 plus the 5. And that's going to be 4 times the square root of 4. And the square root of 4 is 2. So we get 8. So -1, 8 is our coordinate there. So back up 1, and then 1, 2, 3, 4, 5, 6, 7, 8. So there are 3 dots taken off. We need 3 coordinate points. 3 coordinate points is what we're looking for. Okay, so the domain is the x values. So what is our starting point? What is our starting point there? It's -5, 0. And so we're going -5 and to the right forever. So -5 to infinity. Don't forget bracket and parentheses, always parentheses for infinity or negative infinity. Okay, the range now. The range is the y value, and we're on the y-axis because we did not shift up or down. And so that's going to be this guy right here. And so that's going to be on the x-axis. So we're going 0, and then we're going up to 1, 2, 3, 4, 5, 6, 7, launching. Even faster than normal, 0 to infinity. Okay, then last but not least is the cube root. So the cube root is going to be -3. So instead of 0, 0, we're going to be down here at -3, because that means down 3. Now the cube root, right, is usually over 1, up 1. And over 1, 2, 3, 4, 5, 6, 7, 8, up 2. That's usually the cube root. And the reason why that's the cube root is because to go to, like, for example, to do 0, you do the cube root of 0 is 0. And the cube root of 1 is 1. What the? And if you choose a 1, then the cube root of 1 is 1, so 1, 1. But a 2 doesn't work, it's a decimal. Well, what works? What's the next one? How do we get to 2? Well, if we go ahead and do an 8, we should get to a 2, because if we plug an 8 in, then the cube root of 8 is 2. So then we get 8 comma 2. So over 8 up 2. Same with the negatives, same with the negatives. So negative 1 is going to yield a cube root of negative 1, which is just negative 1. And if you plug a negative 8 in, the cube root of negative 8 is negative 2. So that's the parent function, right? Back 1, down 1, and back 8, down 2. 1, 2, 3, 4, 5, 6, 7, 8, down 2. And so that's called the parent function. But what is now happening? What's happening with what transformation is going on? Well, we shifted. What transformation is going on? Well, we took the whole graph and went down 3 because of the negative 3 on the outside. But what about the 2x on the inside? Remember, it's opposite. So this means that you're going to take your x values and then not times it by 2, it's opposite. Right? So what's opposite? What's opposite of times by 2? What's opposite of times by 2? Opposite is divide by 2. So we're going to take your x values and we're going to go ahead and times it by a half. So now we're going to do the same y values, we're just changing the x values. So that means that down here, negative 3, we're going to go over a half and up 1, right? Because we're going to go ahead and times these x values by a half. We're going to go ahead and times it by a half. We're going to go and times it by a half. So we get a half of the x value, and we get, what's half of 8? 4. So we're going to go ahead and go over half, up 1. Over half of 8 is 1, 2, 3, 4, up 2. And so there, my friends, is the actual graph, like that. And then back half, down 1. And then back 1, 2, 3, 4, down 2. So the y values stay the same. It's the x values that are being shifted here. Negative infinity, positive infinity. Negative infinity, positive infinity. Way-o. Negative infinity, positive infinity. Good, good, good. Okay, next page. More graphing. What the woo? So just think about what I said there with your parent function. And then just go ahead and do the shifting. Go ahead and do the shifting. So our parent function is, again, 0, 0. We have 1, 1, 2, 8. And the cube root of 8 is 2. So we have 8, 2. And then negative 1, and negative 8, negative 2. Okay, what do you think? You try now. Pause me. What are we going to shift? What are we going to shift? So we're going to go right 1, up 3. Is that what you got? So right 1, up 3 is our new origin. We're going to go ahead and follow these guys. So that's your origin now. That's your origin. So now we're going to go ahead and go over 1, up 1. So over 1, up 1. And then we're going to go over 8, up 2. So from the origin, 1, 2, 3, 4, 5, 6, 7, 8, up 2. And now we're going to go, whoa, that's not that good, Nebo. Try again. Okay, so over 8, up 2. A little better, not much. We'll take it. And then we go back 1, down 1, back 1. Right, that's your negative 1, 1. And then negative 1, 2, 3, 4, 5, 6, 7, 8. Wow, 8 is there, I guess. Wow, did I miscount? Oh no, you're going over 1 because of the right one. So this should actually be at 7, yeah. And then down 2, and then down 2. So that third coordinate right there should actually be at the 7 mark, right? Should be there at the 7 mark. So yeah, so that coordinate should be negative, so that coordinate right there should be negative 7 and then up 1. Okay, good. Okay, so I think we got that. That was our big origin. Okay, looking good. Negative infinity, positive infinity, negative infinity, positive infinity, negative infinity, positive infinity. You got this. Keep trying your best. Keep trying your best. That's a down 3, and the y values are going to launch now. So that's a down 3. And now that's going to affect the y values. Y values. You're going to multiply by 2 to the y values. Multiply by 2. So we do an XY table again. We do our parent function. But this time we're going to go ahead and, multiply by 2 to the y values. So that means that we're going to go ahead and times this by 2, by 2, by 2, by 2, by 2. So this becomes a 4, this becomes a 2, we get 0, we get negative 2, and we get negative 4 for our y values. So we shifted down 1, and now we're going to stretch upward and downward by 2. So negative 8, good. So from here, we're going to go negative 8, and then we're going to go down 4. So we're going to go 1, 2, 3, 4. Negative 1, so it means we're going to go back 1, down 2. 0, 0, over 1, up 2. So over 1, up 2, from the origin. So over 1, up 2. And then over 8, up 4. 1, 2, 3, 4, 5, 6, 7, 8, up 1, 2, 3, 4. And there we have it. Definitely launching higher, faster. Launching higher and faster. So the domain and range, negative infinity, positive infinity, negative infinity, positive infinity. Nice. So write an equation, include f of x or y in your answer for the function shown on the graph. So we got to come up with the function now, right? Come up with the function. Well, originally we had our function was 0, 0 for our square root. This thing has been flipped, right? Over 1, up 1, and over 4, up 2. So that's the parent function. And so the transformation is we've shifted down 1. So we've shifted down 1. And how far we've gone? 1, 2, 3, 4. So we've gone left 4. Uh-oh, do you remember what left 4 looks like? Remember, opposite sign. Left 4 is actually plus 4. Actually plus 4. There we go. There we go. So plus 4. And then it's going upside down. So there's our negative. And so it's going upside down. So that's a negative radical x there. So the negative means upside down. That means to reflect over the x-axis, right? Reflect over x-axis. Way-o. Upside down. Cool. So this one looks like it's shifting. Oh, try number 16 on your own. I'm waiting for you. Try number 16 on your own. Come on. Try 16 on your own. Okay, it looks like what? What does it look like? Looks like a third root because actually the third power actually goes like that. So this must be a root. Must be a third root. We start off at 0, 0. We're going to shift over 2. So we're going to go right, 2, and then up 1, 2, 3. So we have up 3. So we have y equals the third root of up 3. And then don't forget the right 2. But what does right 2 actually look like? It's actually the opposite. So you think right 2 is, you think it's plus 3, but it's actually plus 2, but it's actually minus 2. There we go. Well, but it's launching. What is it launching? Well, it's going over 1, up 2. So because it's going over 1, and up 2, it probably has a 2 in the front. So you can use your calculator to double check it there. Use your calculator, see if we got it right. So we're going to go ahead and do the 2 first. Then we're going to do the cube root, option 4, of the opposite, what we think, so x minus 2, and then up 3. Let's see if we got it right. Did we get it right? I think we got it right. What do you think? Zoom 6, did we get it right? Yeah, I think we got it right. Why does there look like a hole there? Whoa, like it skips over something. That's weird. Do we have a hole? Is this square root or cube root? Should be cube root, so there shouldn't be a hole there. I'm not sure what's going on. That's weird. Right 2 up 3 should work. Right 2 up 3 should work. Okay, anyways. Okay, beautiful. So there's our equation. It works. Beautiful. So thanks for watching. We're going to do solving next and get you ready. Last video, get you ready for your test. Boom. Remember to pause me. Try it on your own. Do the rest of the practice test by yourself. Pause me. Try it on your own and then push play and learn from any mistakes you might make. But don't copy me. Don't copy. Weird things happen when you copy. I don't know what that symbol means, but somebody gave it to me. Weird things happen. Thanks for watching. See you on the next video. Bye for now.